Students of class 10, Assalamu alaikum. Welcome to our today's class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. Today I want to discuss about your General Mathematics Theorem 25 to 27 from Chapter 8. Now, Theorem 25. The tangent drawn at any point of a circle is perpendicular to the radius through the point of contact of a tangent. This is our general enunciation. It states that if P, just you think on this figure, if P is a tangent and OP will be the radius through the point of contact. Same at the same point, PT is a tangent and OP is a radius. So P is the point of contact. Then we have to prove OPT is perpendicular on OP. So this is our particular enunciation or proposition. Okay, what is our proposition? Just this statement you have to explain by this figure. Okay, here PT plate is a tangent at a point P of a circle with center O. Of a circle with center O. Then O P is a radius through the point of contact P, because P is the meeting point of the radius P and tangent PT. That's why P is the point of contact set. Okay, it is required to prove PT perpendicular on OP. Okay, construction. Construction is here, take Q is any point on tangent. Take Q is any point on tangent. Take Q be the any point on tangent. Just we have taken Q is any point on a tangent. Join O comma Q. Okay. Prove here it is a tangent at a point P. So tangent of a circle must touch a one point of a circle. So if we take the any point on this circle except P, then this point must be lying outside the circle. Okay, hence PT is a tangent to the circle at a point P. Hence every point on PT except P outside the circle. So therefore Q outside of the circle. Q outside of the circle, because Q not Q outside of the circle, only P on a circle, because the tangent drawn at a point P. So any point on tangent must outside of the circle, and this is our language. Okay, therefore Q outside of the circle. Okay, Q is outside of the circle. Here OQ is greater than OP. If any point, it is true not only for Q. If you point Q L in this point, M any point on PT, then this distance must be greater than OP, because except P, others point must out of the circle. So which distance is greater? Of course, those distance will be greater. This point outside of the circle is greater than on point on circle. So OP is the point, P is the point on circle, so OQ is the outside of the circle, so OQ is greater than OP. So it is true, for each point on tangent except P. It is true for each point or all point on tangent except P. Okay, therefore OP is a shortest distance from center O to tangent PT. So OP is a shortest distance, minimum distance from the center O. So each minimum distance or shortest distance is perpendicular on this line. So therefore PT is perpendicular on OP. This is our proved. Okay, now theorem 26. If the two tangents are drawn to a circle from an external point, the distance from that point to the points of contact are equal. Yeah, this is a figure for this statement. Here P is an external point. So PA and PB are two tangent. Here the two tangents drawn from an external point. So PA and PB are two tangent from an external point P. Okay, just this is our proposition. Proposition is PA and PB are two tangent from an external point. Two tangent from an external point. Okay, let PA and PB are to tangent from an external point P. So P, A and P, B are 2 points from an external point P. Okay, then the distance from that point to the points of contact are equal. That means the distance PA and PB and 2 points of contact A and B, these two distances will be equal. Okay, it is required to prove PA is equal to PB. This is our proof of this theorem. Okay, just construction of this theorem. Construction. To prove, we have to draw the necessary construction to complete our proof. The construction is just join OA, OB and OP. We have to join the three just join OA, OB and OP. Okay, join OA, O comma A and O comma B, O comma P. This is our construction. Now our step of proof. Okay. Okay, how we can prove this theorem? Just how we can prove this theorem? Here A is a point of contact for the tangent PA and radius OA. Okay. Here PA hence PA is a tangent at a point A and OA is a radius through the point of contact. Okay, according to our previous theorem, how we can write? According to the previous theorem, we can write PA is perpendicular on OA. PA is a perpendicular on OA according to our previous theorem 25. Okay, so angle PAO is equal to 1 right angle. Similarly, for this point, we can write PBO is also 1 right angle. Okay. Now, for the theorem, similarly, angle PBO is equal to also one right angle. So the triangle POA and POB both are right angle triangle. Okay. Now both are right angle triangle. Okay, in triangle, so in triangle, in right angle, triangle POA and POB both are right angle triangle because they are this angle and also this angle are 90 degree. Already we have proved two angle are 90 degree. Now from two triangle, how we can prove it congruence? Because their side hypotenuse, this is 90 degree, their hypotenuse side is OP, and also for this triangle also OP. So OP is the common side and hypotenuse of those triangle. Okay, so hypotenuse OP is equal to OP because the both sides are common side, and OA is equal to OB because radius of same circle. Radius of same circle. Now, so they are one angle of this triangle, another angle of this triangle are 90 degrees. So it is required to show the triangle POA is congruent to triangle POB. If two triangles are congruent, then how we can prove PA and PB are equal? So it is clear because their two triangles are congruent. So they are all angle, their corresponding angle and corresponding side will be equal. So their side PA, therefore PA is equal to PB. This is our proof. Okay. Now theorem number 27. Theorem 27. If two circles touch each other externally, the point of contact of a tangent and the centers are collinear. Okay. Our proposition is just A and B are center of a circle, this and this. Okay. A two circle with center A and B. Two circle with center A and B. Okay. Two circle with center, their center A and B. Okay. Now two circle Two circle with center A and B touches externally at point O. Two circle touches externally at a point O. So, the point of contact of the tangent and centers are collinear. Point of contact this, so center is A and B and are collinear. So it is required to prove it is required to prove A comma O comma B are collinear. Okay, this is our proof of this statement. Okay, now construction is just you think construction is here O is a common point for both circle. Common point for both circles. Okay, so is a common point, so we can draw a tangent through the point O. That will be the common tangent. Okay, so draw the common tangent. Draw the common tangent POQ at O. Okay, this is our common tangent. So POQ is our common tangent. Okay, and we have to prove A, O, B are collinear. So join A, O and O, B. Join and okay, this is our construction proof for our proof. Okay, now proof of this theorem. Okay, now proof of this theorem is okay. Here POQ is a common tangent. POQ is a tangent and OA is a radius OA is a radius through the point of contact. Point of contact. According to our theorem 27, at same point tangent and radius are perpendicular each other. So POQ OA is perpendicular on POQ. This tangent, this radius is perpendicular on POQ. Okay. Therefore, so since OA is perpendicular on POQ, so angle POA is equal to 1 right angle. Right angle. And similarly, we can say, similarly for this circle, also POB also 1 right angle. 1 right angle. 1 right angle. So, angle POA plus angle POB is equal to 1 right angle plus 1 right angle is equal to 2 right angle. 2 right angle. Here angle POA and POB together 2 triangle is equal to together 2 angle is equal to AOB. Okay, this is together 2 angle is equal to AOB is equal to 2 right angle means 180 degree, and 180 degree is called a straight angle. Okay, so 1 straight angle. 1 straight angle. Okay, straight angle, that means point AOB creates a straight line. Okay, therefore A, O, B are collinear. Collinear means that the 3 points lie on a same straight line. This is called a collinear, because here why the 3 points are collinear, because they are lie on a same straight line, because angle AOB creates the one straight line. That's why AOB lie on same straight line, and if 3 points lie on a same straight line, it is called a collinear. This is our proof of theorem 27. Okay, this is our